Okay, so when you want to find the area between these two curves and no bounds are given, it's possible that they meet at only 2 points. So you have to find those 2 points. I'm going to call them x1 and x2. Then it's going to be from x1 to x2, the function that's on top minus the function that's at the bottom. And if you make a mistake about the order of these two, then the answer is going to be negative. Then you would know. Yes?
Yeah, I understand this part, but this problem gives you 3 points.
Okay, so I
So
was
when
going
I'm
to
having
answer,
3
I was
points,
going to
when
talk
I'm
about that next. If you have
yeah, but
three, if you have like this, so imagine you have 3 points of intersection, x1, x2, and then x3. Yes. Then you will have to calculate this area and then calculate this area and then add them up. So you'll have to calculate integral from x1 to x2 of the function that's on top. So this is the one that is on top minus the one that's at the bottom. So let's say that this that is on top is f of x, and this one, yeah, and this is the one that's on top, and the one that's at the bottom is g of x. So from x1 to x2, it's going to be, this is f minus g, plus from x2 to x3, here g is on top, g minus f. But when you're calculating each one of them, again, I would not worry about the order. I would just calculate in any order. And then if the answer is positive, I know that it was the right order. If the answer is negative, I know that I have to take the absolute value of that. Make sense?
okay, I understand, but just a question. Can I just take the integral of f minus g for at the beginning and then calculate from x to x2 then plus x2 to x3?
So you mean you can find the antiderivative of f minus g and then use that antiderivative for both?
Yeah, exactly.
Yeah, you can do that. One of them is going to be positive, the other one is going to be negative. The one that's negative, you take the absolute value for.
Okay, okay, I understand. Thank you.
Good. Salma, you have a question?
Sorry, no, I just forgot to below my head.
Okay.
Sir?
Yes.
So would you say that just like as a general revision for tomorrow's test, should we work more on web work or on the exercises in the book?
No, I would work on web work more.
Okay.
Because the test is going to be in the web work.
And if we prioritize, like, if there were some exercises to prioritize from the book, which one would they be? Like the long, like, applied situations, or?
You know, I can write problems in web work. I'm actually learning how to code in web work, and it's fun, but I don't really have time to do all the problems that are in the book. So I'm going to pick from the problems that other teachers have already written, like the ones that I give you in the exercise sets. Yes.
Okay.
So it's going to be from those. It's not going to be something from anywhere else, or but you know, my goal in picking those problems in the exercise sets has been to pick the ones that are as much as possible close to and similar to the ones that are in the book. So there is not actually much difference between the two. Almost all types of problems that you have in the web work, you also have the same types in the book, except for those maybe application ones, like consumer, the cost function, the income function, those of them, there are very few of them in the web work, but apart from that, they're very close. I would say just review all the ones that you have done in the web work. If you have extra time, do the one in the book.
Okay, thank you.
Sure. Salma?
Yes, I was wondering if you can do the problem 15 in the 6.2, 12.4 section, please.
6.2. problem 15?
Exactly.
15. Okay. Yeah, it's a simple substitution. You take u to be sine. You have cos x sine x to the power of 6 dx. Take u to be sine x. Then du would be cosine x dx. So this becomes u to 6 du. Make sense?
Yes, thank you.
Sure.
Can you do partial fractions number 21, please?
Partial fractions 21. Okay, so do you know how to factor the denominator for this one?
Yeah, it'd be x and then x plus 1, x minus 1.
Very good. Then it would be what case? Case 1, case 2, or case 3?
Case 1.
Very good, because you have 1, 2, 3 distinct linear factors. So that means you can write this as a over x plus b over x plus 1 plus c over x minus 1. So minus x squared minus 2x plus 1 is going to be a times x plus 1 times x minus 1. Do you want me to do the rest, or you know what to do? How to do after?
No, I think I can. Oh, I think it's good. Thank you.
Okay.
Could you do number 31 of partial fractions?
Yes, it's very easy. It's you begin with a what is it? A substitution. Sorry, guys. So what you do is you can write this as e to x to the power of 2 dx. You're good?
Okay.
And then you take u to be e to x. And then du is going to be e to x dx. So this suddenly becomes, this would be du. And the bottom you have 1 minus u squared. Make sense?
Mm-hmm.
So, and then this part here is going to be a partial fraction because at the bottom you have u plus 1 times u minus 1.
Oh, okay. I didn't see that.
Yeah. And also don't forget that you can change the bounds so that you don't have to go back to them. X is from -9 to -2. Then u, which is e to x, is going to be from e to -9 to e to -2. So then you would do this from e to -9 to e to -2. And when you're done, you can just use these new bounds. You don't have to go back to the old ones.
Okay, thank you. That makes sense. Could you also look at 32, like just the first steps, like what we should do?
32 is the same. You need this type substitution.
Okay.
The only difference with this one is that you don't have e to the power of x. So you will have to write it like this. You will have to write it as -16 e to the power of x minus 36. At the bottom, you can write it as e to the power of x to the power of 2 plus 5 e to the power of x plus 6. And then here, you would need e to the power of x dx. At the bottom, you need e to the power of x. That is, you multiply by e to x and divide by e to x, okay? Because that then will be du after, and this one will be u. So this becomes, with the same substitution, it becomes integral of minus 16 u minus 36. At the bottom, you will have u squared. You will have u squared plus 5u plus 6 times u du.
Okay, thank you.
Sure.
Sir, I have a question.
Yes.
Will we have the whole hour and 45 minutes to do it tomorrow?
You're gonna have 100 minutes. It
Okay.
starts at 12:10, ends at 1:50.
Okay, and so it's just the answers that count, right? It's not, we don't send you our work after?
Just like web work.
Okay, perfect, thank you.
And I'm guessing we also only have one attempt.
No, that's the good thing about web work. Depending on the problem, you may get 3, 4, 5 attempts.
Oh, perfect. Because sometimes you.
That's actually the advantage of doing the test in the web work. The disadvantage would be that you may, if you don't know how to do it after 4 or 5 attempts, you get nothing. Yes, but there is a big advantage because in the test, no teacher, I'm sure nobody would verify the answer for you. But the web work does verification, and you know that you have done something wrong. You can go back and double check. So that's the good thing about the web work.
That's perfect. Okay.
Yeah, just wanted to tell you, if there is any true, false, or multiple choice problem, then it doesn't make sense to give many attempts because you can then answer by trial and error. So other than that, if there is any calculations involved, you will get 3, 4, 5 attempts, depending on the problem.
Yeah, because I was thinking, like, imagine like you have a good method to get to your answer, but you just made a little mistake.
Yeah, that's actually the point. It happens all the time, and the students who know how to do it, they're gonna lose marks because of a careless mistake somewhere, a negative somewhere, But with the web work, if you actually know how to do the problem, since you're given multiple attempts, you will eventually get the answer. Okay, and I think it's a safe assumption that if you cannot answer it after a few attempts, then you probably don't know how to do it.
Right.
Okay.
Sir, do we lose points? Like if we use like 2 out of 3 attempts, do we lose some of the points?
No, you can use all your attempts. You don't lose marks for using attempts. Talal?
Yes, sir. Problem 10, 7.1, problem 10. So I'm having trouble with this section, 7.1.
7.1.
The whole thing, I'm always having trouble.
Which one was it? Okay, this is.
So I'm telling you.
I see. So you just need to practice. You just need to practice a lot. This is the part. This is the integration by parts. Yes.
Yeah. So I'm having trouble with this method.
Okay. Let's see. We have x to the power of 2, and then the 5th root of e to the power of x dx, which we can also write as integral of x squared e to the power of x over 5, because this is like having to the power of 1 over 5 dx. You can take u to be x squared, then du. So this procedure, like an algorithm that I do, you have to practice that a lot. And then
so this is the same, but when you take v, dv, and v.
Yeah, you take it like this. And then v is going to be 5 times e to the power of x over 5. Because if you take the derivative of that. I don't understand
this part.
You don't understand this part?
Yeah, just the dv and v.
How to pick them?
Yeah.
Look, you have to think about, so this is the first step, step 1, and this is the second step. You have to ask yourself, from step 1 to step 2, what am I doing? From step 1 to step 2, I take the derivative of u, and I find the antiderivative of v, dv. Yeah? So I have to pick u and dv so that it is easy to take the derivative of u and take the antiderivative of dv. That's it.
Okay, I understand. And then,
Yeah. And then you have to just use the formula. It's uv minus integral v du. So in this case, it's going to be 5x squared e to the power of x over 5 minus and integral of v du. That's going to be 10x e to the power of x over 5 dx. Now, this one here needs another integration by parts. Okay, so this time, let's just focus on, because the 10 is a constant, can go out. So I can write this as 5x squared e to the power of x over 5 minus 10 integral of x e to the power of x over 5 dx. I calculate this, and then I will plug it back in here. And that, the one that I put inside a frame, that can be done by another integration by parts, where you take u to be x and you take dv to be e to the power of x over 5. Make sense?
yeah, I understand. Thank you.
Sure.
Sir, I have a question.
Yes.
So I asked about number 25 earlier. Is it supposed to be like super long, the answer
25.
of partial fractions? Yeah.
I don't know. I haven't done that. But did you do the division?
Yeah. Yeah.
Okay.
And then, because then you have to do the integral of the.
Yeah, because and at the bottom, what you have, you need three letters. You need A, B, and C. You need A over x plus 1 plus B over x plus 1 squared plus C over x plus 1 to the power of 3. So it's a long problem, yes. It begins with the long division, and then you need to use partial fraction.
Oh,
Case 2.
So it's
case 2.
So it's long division and then it's case 2.
Yes.
Okay.
Sir,
Yes.
could you do in the textbook page 489
Which section is that?
7.1?
7.1. Which ones?
It's on page 489, next page. And question 30.
So these ones, 30, yeah?
Yeah.
Okay. So
Like I was able to do it. It's just the end of the answer was wrong, and I don't know where I could fix that, but
okay, so let's take u to be x, then du is
Mhm.
going to be dx.
I said u is ln x. Is that wrong?
Oh yeah, that's better. That doesn't work.
Okay.
X. So u is ln of x, then du is going to be 1 over x dx.
I said like v was x squared over 2.
Is
And then-
x dx. That means v is going to be 1 over 2x squared.
Yeah.
So you get 1 over 2x squared ln of x minus integral of v du. That's going to be 1 over 2x dx. Giving us 1 over 2x squared ln of x minus 1 over 4x squared.
Yeah, but where did you get the 1 over 4? That's what I don't understand. Like, where does that come from?
Oh, there's already a 1 over 2 here.
Yes.
And the antiderivative of 1 and the antiderivative of x is 1 over 2x squared. So 1 over 2 times 1 over 2, 1 over 4.
So is it like a substitution that I'm supposed to do?
No. Look, antiderivative of 1 over 2x dx. Isn't that the same as 1 over 2 antiderivative of x dx? That's 1 over 2 times 1 over 2x squared plus c. It's 1 over 4.
Oh, okay. Okay, I mean, I was just kind of, that was one, like, I kind of do it a bit differently, but like, no, like, I understand why. I've just always been confused as to where the extra 1 over 2 or the extra fraction comes from. So you're saying the derivative?
There already is a 1 over 2, and there is
Yes.
another one from the formula when you find the antiderivative of x, which is 1 over
Okay.
2x squared.
Yeah, so in this case, we need to find the antiderivative of v times du, right?
Yeah, we have to find the antiderivative of this.
Okay, but
function
so,
here.
and it would just be basically the initial fraction that I get from the antiderivative, and then I put another one because that's anti-deriving it, right?
Yeah, because this one is an antiderivative. You begin with a difficult antiderivative, you come to this point where you have to do an easy one, and then you finish the problem like this.
Okay. No, yeah, like I got the first part right. I did the first part completely right, and then it was just the last part just because I'm missing a 1 over 2, an extra one, and that's all.
Yeah, okay.
Thank you.
Sure.
Could you do inverse trig problem 13?
Inverse trig problem 13. Okay. So for this one, if you take the antiderivative of the given function, you're going to get 4 minus 3 arctan of x. Very good so far?
Yes.
Yes or no? Okay. Then if you plug in 1, you're supposed to get 6. But 1 gives you 4 minus 3 arctan of 1. That's supposed to be, so there is also a plus c. I forgot about that. Plus c gives you 6. So 4 minus 3 times this, you can get using your calculator. You're going to get, and the way I would recommend that you do is you put your calculator in degree mode. This will give you 45 degrees, and then you can convert from degree to radian. That would be pi over 4. So C is going to be 2 minus 3 times pi over 4. So you replace C here.
Okay, thank you.
Sure. Okay, guys, it's 11:16. I'm going to end the meeting and see you guys tomorrow. Try to be early. I'm going to be early, maybe 10 minutes earlier, just to make sure that everything is all right. The test begins at 12:10. But again, I recommend don't be late. Try to be early. If you're there 10 minutes earlier, that's better than on time or even late. And if you have no questions, I'm going to end the meeting right now.
I have a question.
Yeah.
Number 12 of inverse trig. So
12 of inverse trig. So this one, what you have to do for this one is you have 1 over x squared plus 6x plus 58 dx. There is a formula for that. I just tell you this, the first step, and I let you do the rest, okay? There is a formula for this. If you have 1 over u squared plus a squared du. So there is a formula for this that you can find in the notes, okay?
Okay.
Now, you have to bring this to this form. So you can write that as 1 over x squared plus 6x plus 9 plus, what is 58 minus 9? 49 dx. So this becomes integral of 1 over x plus 3 squared plus 7 squared dx.
Okay, I get it. Okay.
Yes.
Thank you.
Sure. Any other questions? Okay. So I'm going to end the meeting right now. Bye, everyone.
Bye, sir.
Bye.
Bye.